Good morning. We're doing an update today on the wheat and the oats and the barley, the rye, the triticale. And so now it looks like big, tall, beautiful grass. Now if you remember when we planted this, I filmed this to show you how we planted it, and I just put a couple of seeds in each one of these. Some interesting things have happened. First of all, what I want to tell you is that this was an experiment, and I hesitate to show experiments because people think I'm crazy and I'm a weirdo. I hesitate to show experiments because it's experimental and it may not work. But the seeds did grow good, so I know I have good germination in the seeds I had. I think I probably had a good 90-95% germination rate, which is really great. But I want to just point out some of the a couple of different things here. If you look at this closely here, but these roots are coming out, and they're big, they're beautiful. You can see a lot of the root hairs on these, which is pretty exciting to be able to see those root hairs up close. So that's a fun thing. By having them in a pot like this, we can get an up close. We could even put these under the microscope if we wanted to, and we could understand what these look like a little bit better. This is the RMSA barley right here, and this one, this is triticale, and the grass looks a lot finer, thinner leafed, so it's fun to see the different types. If nothing else, this is good to see what the different species of grains look like when they grow and they come up. They all look like grass, obviously, because that's what they are. I looked up a 15-day extended forecast for our area, and it's showing the nights in the 20s and 30s and not down in those single digits. So I think it's time to go ahead and get these guys planted outside. So I have two ways I'm planting them. I have the plugs here, so the plugs will just come out. So we can just, let me find one here. I can pull any of them, I guess. But it's root bound, lots of roots on there. And so we can just make a hole with the dibble and stick these in the ground. And then the ones in the biopots, like this one right here, some of these are a pot that I had last year. I got them from Amazon. I don't like them. They say they decompose, but I still have them in the soil out here in the greenhouse. They never decomposed. So, but I want them to decompose, so I'm not going to buy these anymore. I'm just going to use the paper pots. Right here I have a peat pot. So this is a peat pot, and these do decompose really well, and you can see the roots coming out of here. So this is a 6-row barley. And yeah, anyway, it's pretty exciting to be able to see some of these things coming up. So I'm excited about this project. We're going to go ahead and plant them outside. So let's show you planting them outside. Okay, I have this place out here that just has mostly subsoil from building the Wallapini and digging out a spot for the other summer greenhouse. And we had excess dirt left over. This is within the deer fence. So this helps to keep a lot of the predators out that eat the food. And so we wanted to use this area to be able to grow things, but this is not a very good garden soil. So this is going to be a test. I'm going to try to take my compost, make a compost extract, and plant in here. So I'm planting rye, wheat, oats, and triticale in here. So right now we're going to plant this one, and I don't know what it is. Let's see what it is. This is the Sinnet Field wheat. It's an ancient wheat. So we're going to plant it here. And so I've done nothing to this soil to prepare it. And I'm just going to put this tag in the ground right here. I'm going to use the dibble, and I'm going to plant these plants 1 foot apart. I'm not measuring, I'm just guessing. So I'm just going to put just going to dibble a hole down right there, and right there. So there they are. Now a foot this way, and I'm just going to make three rows here. Now we need to remember when we're growing things what succession they grow in. Are they early succession, mid succession, or late succession? Well, the grasses of the world are kind of a mid succession plant. So we need a bacterial to fungal ratio that is kind of even. Kind of the same amount of fungal biomass and bacterial biomass. But this dirt was just dug up, it was put here last year, and I have not even done a test on it because I don't need to. I know because it was a subsoil that this is going to have low fungal content. How do I know that without looking at it under the microscope? Because there's no fungal food here. There's very little carbon in this soil because it's a light color. There's very little organic matter in this soil. And so there's no food for the fungus to eat. And since there's no fungal food, I know that they're not here. And I can know that because every living organism needs food to eat. If I have a 1,000-acre cattle ranch, but it's just sands like the Sahara, how many cattle will I have? None, because there's no food for them. Even if I put them there, I won't have any very long because there's no food. So whatever organism you have, the food supply needs to be there. So I'm putting these plants in here. They need some fungus in the soil to grow well. They need bacteria to grow well. And they would do really good with protozoa and nematodes, obviously beneficial nematodes and microarthropods. So we're going to have to do something here. Why aren't I doing that before I plant? Because this is an experiment. So we're going to plant them in here just like these are going in these holes. These plugs are going to go right in these holes. I'll come back with my watering can and we will put the compost extract on here, and that is full of humic acid. And I know that because it's very dark, this color of a dark chocolate bar. And I looked at it under my microscope and it was filled with flagellates and amoebas and fungus. It was a very good compost. The compost I chose to use was the compost from my worm bin. So we're going to put this out here and put one inoculum out here, and then we will test it. Now I'll be able to test the soil from right there, with 2 feet away, and then I'll test it right here where I put the inoculation, and we will see what the difference is. And I will inoculate this as many times as I need to get a bacterial to fungal ratio that is about equal. So let's go ahead and plant these in here. So it's pretty easy to plant them. When they're this big, they're root bound, which means the roots are holding the little piece of soil together, and we just put them in, and I put a little bit of loose dirt on top. So I just lift them out, and we just drop them in. Just drop, drop, and if it's gonna break the root ball up, I'll push on the bottom. That one was not as root bound as it should have been. So I'm just putting these in here. So what this experiment is hopefully going to show me is if I could go to somewhere like the Sahara or Mars or somewhere that has soil that has mineral content in it, but it does not have organic matter in it. If I put the microbes in here, is it going to grow? Now you got to remember that the microbes have 2 food sources. It's the detritosphere, and that means organic matter in the soil. And the other food source are the exudates coming from the roots of the plants. So when I inoculate this with the compost, the microbes should not die because the living plants will keep them living. And if I wanted them to live even longer, I could put a couple of inches of compost on this soil, and that way they would have an immediate detritosphere. And so that would be a second food source for them. Okay, that looks beautiful. I'm doing this in nice neat squares, kind of like square foot gardening. When you dibble a hole, just push it straight in, move your dibble back and forth, and bring it out gently. And it shouldn't cave in. If it does cave in, your soil is too wet. I mean, your soil is too dry. If it's too wet, it sticks to your dibble. And then we just lift our plants out and we pop them in. Just like that. And then it's a good idea to cover them just a little bit, like that. Just give them a little cover. And I have one more of this variety. So we can put it in this hole right here. And we are done. We're done with that variety. Okay, when I'm talking about all these organisms, it's kind of a new way of thinking about the agriculture that we're doing, but it's really not new. It's really not new information. It's new science because we understand what's happening better in the soil. But people have been growing food for thousands of years using this type of a method. This is a fancy dibble I have because I made it from a modern shovel that has a fancy handle. But a sharpened pointed stick is the tool of the Hopi Indian. And they would plant very similar to the way I am now. And they were good farmers. They produced good food. The way I'm doing this, I feel like I'm going back in time more than I am using new science. So I use a lot of fancy words like arthropod and nematode. But we don't need to worry too much about that. You don't have to be a scientist like I am to grow good food. All you need to do is do the methods and then your food will thrive. You don't need to know exactly why it's thriving. If you want to know, then I will tell you, and that's why I give so much detail. But I certainly don't want this to be frustrating and make it seem hard. If the things I talk about seem complicated and it makes it seem hard and impossible, then don't worry about all the little details that I'm talking about. Just do the simple things. Just find a piece of soil, make a compost, make an extraction of the compost, plant your seeds, poke a hole in the ground with your stick, put your seedlings in, bring your compost extract out here, and put the extract in the ground on top. If you want to go a little further and make sure that your extract is super good, send me a sample. I'm a laboratory. I can do a soil sample on it, and we'll see how it goes. Okay, let's pop these in. So this is the easiest thing in the world. This is not the traditional way of planting grains. And if grain farmers are watching this, they'll think I'm crazy. But that's okay because I'm doing scientific research. I'm not trying to grow semi-loads of grain. And so context is important. We're growing several different kinds of grains. We have modern wheat, we have ancient wheats, and we're going to see which ones do the best in these types of conditions. Okay, so that one wasn't coming out good, so I pushed on the bottom. Most of them come out pretty easy. So if they give you trouble and they're not coming out, just push on the bottom and that'll help them come out. Got the cordless drill, I've got the auger. I changed my auger a little bit because it wore out last year. So I had a big drill bit for drilling through concrete, and we welded that on to the end of the auger, and it's been working great. Okay, I want to talk about why I'm planting these a foot apart. Here's a barley plant, and I put 2 seeds in each of these. Some of them may have got 3, but if you go back and watch that video where I was planting them, I put 2 seeds in each one. But this barley plant is a good example because I have 2 main plants coming out here, I'm sure from the 2 seeds, but I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 stems coming up. Each stem of grass that comes out is going to have a seed head on top. If you plant your cereals really close, then they will have 1, 2, or 3 stalks coming up because they'll be crowded. If you plant them far apart, they will spread out and have more stalks with more seed heads. So traditionally with a big tractor, we're planting seeds about 8 inches apart, 6, 8 inches apart, depending on the type of planter you have. And then in the row, you can adjust that so they're just piling them in there. So there's 5, 6, 10 seeds in an inch. That'd be way too thick. So farmers usually spread it out so there's, you know, maybe 2 seeds per inch or whatever. But we don't figure it out that way. We figured it out in pounds per acre. So you know, a normal way to plant some of these cereals would be more something like, you know, 50 pounds per acre or 30 pounds per acre, whatever. There's different ways to figure it out depending on a lot of factors. But what we're doing is we've got 2 seeds in each of these biopots, and then we're putting these biopots about a foot apart. It looks like the way I'm drilling those holes, they're actually more like 14 to 16 inches apart. So we're going to set these in, and these will come up and they'll have these multiple stems. Now when a plant has a multiple stems, it's called a tiller. The little shoot that comes off the side is called a tiller. I'm interested about the etymology of that word and where it comes from, because we could talk about tilling the soil. Sometimes tillers are called roots that spread and go down. In the cereals, we call them tillers that come out and come up. Even fava beans, they're not a cereal, but I've heard a lot of people refer to those as tillers. So it would be interesting to do some research on our language, find out where all that comes from. But this is a barley, and so we're going to just start setting these in here. This is the update on my experiment with small grains. It's been fun to be able to deal with these cereals, watch them grow in the greenhouse, and to be able to transplant them out. Hopefully this has helped you to have the best garden in the world. Hopefully this has helped take the complicated part of growing food. Hopefully this has helped to simplify food growing for you. Thank you very much. Share this with your friends and family. Ask them to sign up on Patreon so that we can continue to bring you the very best knowledge in the breaking science of food production.